The reason that the global climate model is not sufficient for regional application is that the purpose of the global climate model is to simulate the long-term global scale climate change. So given the limited computational resources, we made a trade-off. Scientists made a trade-off between the simulation times, the global coverage, with the local detail informations. So they are using a bigger grid points that to represent the processes in the model, which could not really resolve the local scales. So one information that the global climate model can miss is the detailed topography or coastal information. For example, the mountains and the related temperature changes due to the mountains could be missed in the global climate models. So downscaling is actually a practice that to link the large-scale climate information with the local scale climate information, which is relevant to the local applications. So it is important to do downscaling because many issues that we are concerned in human society is not really represented in the large scale climate information provided by the local global climate models. So there are basically two types of downscaling methods that is currently used. The first one is the statistical downscaling, which is to get the local climate information based on the statistical relationship established between the large-scale climate information and the local-scale climate information. And it has an advantage of being faster and cheaper compared with the dynamical downscaling. So on the other hand, dynamical downscaling is to use a numerical model which consists of a physical understanding that we have for the climate system. So it takes a lot of computational resources to run a physical model to do the dynamical downscaling. However, it's more physically consistent and you can use it for future scenarios. It's good because the different regions have different conditions in terms of data availability. So we have different applications, like sometimes we really need to know how the future is like. So it's better to use both so we can have a complementary approach to fit in the different regions' requirement. So in aspect, the downscaling play an important role in bringing the local informations to the stakeholders. So for example, in the Emilia-Romagna region, Italy, that city planners actually would like to know where in city like Bologna has a heat wave, so they can do some city planning in advance for in response to future climate change. So in this case, the information from the global climate model may not be sufficient for them because they already go down to these city level and the street levels of details. So then dynamical downscaling could help in this respect by providing this really detailed city level information for them to do the city planning.